Sorry, the internet connection was it was disconnected actually. Okay, now I am audible.
Yes, sir.
Okay, so actually the connection was lost. So now what I was saying, that we have seen that how the one-way ANOVA is actually uh, how the one-way ANOVA is actually calculated. Okay, so there is no problem. So now uh, um, we will consider that how to do the two-way ANOVA. So in that case, you can understand that in two-way ANOVA, that sum of square total, this will be the same like one-way ANOVA. Why? Because all the elements are same. Okay, there are a total of 18 elements. Okay, and the same 18 elements you will get for whenever you will consider the two-way ANOVA. So this will be same. Now, if you consider the sum of square between, okay, sum of square between, then also the age wise and gender wise these things will be same, and you will get an additional sum of square between and an additional degrees of freedom for, because to in order to consider the interaction effect. Okay, but in case of sum of square within, the calculation will be different for all the cases. Okay, the sum of square within calculation will be different for all the cases. Even for age wise it will be different, for gender wise it will be different, and whenever you are considering the interaction between age and gender, in that case also it will be different. Why? Because in that case you are actually dealing with the sum of square within, means you are considering actually uh, sum of square within. Whenever you are considering, then you are simultaneously taking into account the age wise and gender wise. Okay, so actually you are having 6 blocks, 1 2 3 4 5 6, or 1 2 3 4 5 6, 6 blocks you are simultaneously you are considering. Okay, so let's take a look at how the calculation is done. Okay, let's take a look at this table. Okay, so sum of square for first factor or gender, it is the sum of square is equal to 32. The degrees of freedom is 1, we have already seen, and the mean square is 32 by 1 is equal to 32. You can see here 32 by 1 the mean square. Okay, sum of square, this is actually sum of square between. Okay, so this is 32. The sum of square, the second factor, the sum of square age 93 and 2. Okay, you can see here that 93 and 2. Okay, the same thing you are putting here. The mean square is 93 by 2 is equal to 46.5. So 93 by 2 is equal to 46.5, that you are putting here. Okay, sum of square for second factor or age. Then you are calculating sum of square within error. Okay, sum of square within error, you need you will be calculating. Okay, so how to calculate this I will show you. Okay, and sum of square total is 217, just like this 217. Okay, so that you are also putting here. Now you need to calculate for sum of square within error. Okay, so how you will calculate sum of square within error? So in order to calculate sum of square within error, you will have to sum of square, you need to consider all those 6 blocks that I just said. Okay, so you can understand that the mean of these blocks is 6. The mean of these blocks is 7. This mean of this block is 10. The mean of this block is 7. The mean of this block is 10. The mean of this block is 14. Okay. So you need to subtract each and every element 4 minus 6 whole square plus 6 minus 6 whole square plus 8 minus 6 whole square plus 6 minus 7 whole square plus 6 minus 7 whole square plus 9 minus 7 whole square. Okay. So in this way you need to calculate all these things. Okay. And ultimately you will be, if you add all those things, you will be getting total sum of square 68. Okay. Now, why we are doing this kind of calculation? Because whenever you are considering this, if you are asked that this block, whatever what is represented by this block, you will say that this block is representing boys course of 10 years. So you are considering boys gender as well as the age group. Okay, you are considering the boys and as well as you are considering the age group. Okay, so but earlier when we considered only one way ANOVA, we did not consider these blocks, because if you consider gender wise or age wise, only you are considering this, you are the total entire thing, you column you are considering as a block. Okay, the total thing you are considering as a block. So whenever you are calculating the sum of square within, you are basically subtracting the each and every element from that, each and every element of a particular column from this average, from the column average. Okay, you are, whenever you are in case of one way ANOVA, whenever you are calculating the score of sum of square within, okay, what you are doing, you are subtracting, whenever you are calculating this, that means variance, you are subtracting each and every element from these, from a particular column, from, you are subtracting it from your these values, from the column average values. Okay, why? Because you are not considering the gender here, you are not considering here the age are here, so you are ultimately getting, you are having 3 blocks. Okay, here also you are getting there are 2 blocks. Okay, whenever you are considering the sum of square within for one way ANOVA, but whenever you are considering both simultaneously, then instead of 3 blocks you are having 6 blocks. Okay, because you are considering the age and gender simultaneously. So sum of square within will be 68 and the degrees of freedom will be 12. Why 12? Because you are getting 6 blocks and each block you are having 3 elements. Okay, so the degrees of freedom for each block will be 3 minus 1, 2. So for each block the degrees of freedom is 2. So you are having 6 blocks. So 6 into 2, you are having 12. Okay, so sum of square within, this will be 68, 12 and mean square. This will be this part, if you want to calculate the numerator part, it will be 68 by 12 is equal to 5.67. Okay, so sorry, this part, numerator, not numerator, the denominator part, it will be the mean square, it will be the 68 by 12, the sum of square within, it is 68 by 12. Okay, so in the sum of square for the first factor, whenever you are going to calculate the F score, you will divide it by 5.67. You are earlier, you can see that earlier you have divided it by 7.13. You can see that 46.5 is divided by 7.13, but here 46.5 is divided by 5.67. Here you can see that it is divided by 168 by 16, that means 10.5. 32 is divided by 10.5. Here you can see that 32 is divided by 5.67 to determine the F score. This is the difference between one way ANOVA and two way ANOVA, because in one way ANOVA the sum of square within that you will get the same sum of square within you will not get in two way ANOVA, because you are considering both the factors. Okay, and then you will be considering sum of square both factors. That means it is basically the interaction effect. Okay, so how you will calculate the interaction effect? You need to calculate the interaction effect. Age wise you have considered, gender wise you have considered, and taking into account both simultaneously. Okay, so you can name it that age wise, suppose in this case sum of square both factors. How can you calculate this? You know already that your sum of square total is 200. So if you do 32 plus 93 plus 68, you sum it up, then you subtract it from 200, you will get 7. You know that total sum of square is 17. So you 12 plus 2 plus 1, okay, 14 plus 15. So 17 minus 15 will be 2. So it will come out to be 2. And the mean square will be your 7 divided by 2. Okay, so it will come out to be 3.5. And your F score will be 3.5 divided by the mean square divided by your the sum of square within. Okay, 5.67, which will be 0.62. Okay, so now your table is actually complete. Okay, so in this case, in case of 2A ANOVA, you are considering, just have a look, try to understand the difference. In case of one-way ANOVA, you are calculating sum of square first factor, that means gender, without considering the age. Okay, there will be no case of age. Or you can also do, you are not considering the gender, you are only considering the sum of square, the factor age. Okay, not considering the gender, that may be the case. Okay, and you will be considering only the sum of square within, taking into account the age. But here you are considering the sum of square the gender, sum of square age, okay, sum of square for both the factors, that means the interaction effect. And whenever you will calculate the sum of square within, okay, you are taking into account gender and age simultaneously. And that's why this F score for the gender and age, they are actually also they are getting changed. Okay, so this is the calculation procedure. Okay, but whenever you will you don't need to do all these things manually. This is the manual procedure that I am taking, that I am making you understand. But you don't, you will not be doing all these things manually. You just you will use Minitab software or any other kind of software, and it will automatically give you the scores. Okay, F scores. And you can see that, so what will be the result? In case of result, the time is going to finish. The remaining time is just 2 minutes. Okay, so let me discuss about that. This will be performed this cannot be performed, you don't need to do this performed manually. And also you don't need to look at the F scores, okay, because the p values will be given, and from the p values you can very easily understand that which particular hypothesis need to be rejected, on which particular hypothesis you cannot reject. And if you have a look at this one, the first pair of hypothesis, okay, then your F statistic is 5.64, okay, and the cutoff value is 4.75. How can you determine the cutoff? Because your alpha is equal to 0.05 level you are considering. Okay, sir, can you repeat how you get this sum of square of both is 7? Yes, definitely. The sum of square for both factors 7, because if you consider, if you add all these things, 32 plus 93 plus 68, what you will get? You will get 193. Okay, so if you subtract from 200 from 193, you will get 7. Okay, so this is the thing, the way you can do it. Okay, so So yes, so here, so here you can see that the 4.75 is the cutoff. Why 4.75 is the cutoff? Because your if alpha value you are considering 0.05, okay, and your the degrees of freedom, 2 degrees of freedom you need for your F distribution. The degrees of freedom are 1, 12, F1, 12, F1 degrees of freedom 12. So the intersection point is 4.75. Okay, so here is the cutoff value, and your F statistic is 5.64. Okay, so you will reject the null hypothesis. Okay, so that means there is enough evidence that gender is having a significant effect on the test score. Okay, so just like the second pair of hypothesis, if you look at, you are getting the F score as 8.2 for age. Okay, and your